Welcome everyone to the study guide review video for the Unit 2 quiz. Let's just dive in. Question 1. Which table represents a proportional relationship? So there's just one right answer here. It's multiple choice. We know for a proportional relationship, when you take x, you multiply by a certain number, the constant of proportionality k, and that'll give you y. And that's going to be the same number for each. So you can find kind of like a scale factor or that constant of proportionality. We also know that when we have proportional relationships, sort of equivalent to what I just said, is that we're going to have equivalent ratios. Right, so we're going to do y, like y divided by x here, or this divided by this in this case, 10 divided by 4, 15 divided by 8, and we should get the same number each time, okay, which will be that constant of proportionality. Okay, so if I do that for A, I can do 5 divided by 2, I can do 10 divided by 4, and I can do 15 divided by 8. 5 divided by 2 is 2.5, 10 divided by 4 is 2.5, but 15 divided by 8 is not 2.5, that's going to be 1.875. Since those are not equal, we don't have a constant k, right? This would be times 1.875, but this would be times 2.5, not the same, so not A. Okay, doing it a little faster here then for B, we can do the same thing. We can do 5 divided by 2, we can do 12.5 divided by 5, and we can do 25 divided by 10. And when we do those for all of them, we're going to get 2.5. Okay, so we do, in this case, have a constant of proportionality. To get from x to y, we can multiply by 2.5, always. So that's going to be our proportional relationship. Okay, in C and D, we could do the same thing, and we would see that these are not equal. And in particular, in C, we're adding 1, right? This is like addition. Okay, but when we're adding, that's not a constant of proportionality. Okay, constant of proportionality and proportional relationships is all about multiplying. So that won't work. And nor will this. There's not a constant number that we're multiplying by. All right, awesome. Question 2, explain why this table does not represent a proportional relationship. So along those lines, you just need to explain, right, what does it mean to have a proportional relationship, and why is this not this? So to do this, right, in a proportional relationship, there is a constant of proportionality. So I'm going to write that first. So as I wrote, in any proportional relationship, there's a constant of proportionality that you multiply x by to get y. Right, it needs to be the same number for all pairs of numbers, but we don't have that here. And right, I did division. I did 11 divided by 4 here, 11 divided by 4, and we get 2.75. So if we just had those numbers, the constant of proportionality would be 2.75. But then if I do that for 12 and 5, I divide them, I get 2.4, and 13 divided by 6 is 2.16 repeating. So we don't have a constant, the same constant of proportionality, so it's not proportional. Okay, it doesn't have to be as long of an answer as mine, but it does say explain, so you should really have the words to explain that, okay, not just the math. All right, question 3. Select all of the proportional relationships. Okay, so these are all from equations. Okay, so things we know about equations for proportional relationships. We know that they do not have exponents. So this one's going to be wrong because proportional equations don't have exponents. Okay, we also know that proportional relationships don't have addition or subtraction. For a proportional relationship, just like I wrote above, you multiply x, or some quantity, by some constant number, and that gives you y. So this here, that's going to be proportional. Okay, that's in the standard form y equals k times x, where k is the constant of proportionality. We have the same thing for this next one. Oh, I'm missing my thing, but that one's also right. Okay, 17 divided by 12, that's a fraction, okay, but that doesn't change anything if we rewrite this. If you just do 17 divided by 12 in a calculator, you'll get 1.8. So this is actually the same equation as that one, just written in fraction form. So that's also right. X is being multiplied by a constant number, and you get y. And then I think this last one is the hardest, but this one is not correct because here we're dividing by x. We're not dividing by 1.8. It'd be fine if we were doing that. But here we're dividing by a variable. And if you're dividing by a variable, then you're not dividing by the same number each time because that variable x is changing each time. Okay, so you can't divide by a variable. Okay, and we'll see the graph for that eventually, but that's going to be a really complicated graph that you won't see until high school. Dividing by a variable, it's changing each time, so you're not multiplying or dividing by the same number each time. Okay, so just these two there. Okay, question 4. Mr. Vega is mixing sugar and baking soda while baking. The number of cups of sugar, S, that are needed for B cups of baking flour is described by the equation S equals 1.25 B. So 1.25, sorry, there we go. S equals 1.25 times B. Okay, so we're going to use the equation to complete this table. Okay, so what we're doing here, right, if we know that this is saying, this is my equation, so in this case, we're told B equals 1. So if B equals 1, then to figure out S, I just do 1.25 times B, and that'll give me S. Okay, and I'm going to write that down here. Okay, with some color coding. So like B here is in red, S and sugar is in green, right? And what do? I substitute in 1 for B. So I'll get that S is going to be equal to 1.25 times 1. Okay, and then what's 1.25 times 1? That's just 1.25. Okay, and that is my constant of proportionality. The other thing we know is that this number here in this equation, that number is giving me my constant of proportionality. So that's the number we multiply x by to get to y. Okay, so you can also just, for the same reason, say, okay, I know my constant of proportionality is 1.25, so I'm going to do this for all of them. And you just, by hand or use a calculator, multiply my x's, or it's not my x here, it's my b, but the amount of baking soda times 1.25, and it'll tell me how much sugar I need. So I'll get 1.5 there. So we'll get, and 13.75 cups of sugar there. Okay, so I use the constant of proportionality from the equation to fill out the table. Then what does it mean? Okay, so here, if you're confused, this is when you really want to look at your table and look at the units and everything. So if I look at this first row, I see 1.25 in my table. Okay, and where do I see it matched up with? This is like my unit rate. The 1.25 is saying that when I have 1 cup of baking soda, I have 1.25 cups of sugar. Okay, so that means in my recipe, we have Mr. Vega adds 1.25 cups of sugar for each cup of baking soda he adds. Okay, so per cup of baking soda, or for each cup of baking soda, right? Each is saying 1, so here I have my 1 cup of baking soda and 1.25 cups of sugar. All right, and then finally, how many cups of water are needed to mix with 6 cups of baking soda? Okay, so here I'm going to use my equation. I have that S equals 1.25 times B. Okay, I am told here 6 cups of baking soda. So my baking soda we have here in red. Okay, 6 cups of baking soda is what I'm told. I'm trying to figure out sugar. I have my equation, and I'm going to substitute in what we know. Okay, this is my B for the variable of baking soda. Okay, but this is 6. My cups of baking soda is 6 cups, so I can substitute that in. Okay, so all I have to do, just like I would do in my table, is I multiply 1.25 times 6, and I get 7.5 cups of baking soda. Okay, and that's going to be my final answer. In this case, I do have this in the table. I tell you I'm going to give you a different number, though, in the quiz. So you want to be able to do this. But all you need to do is, just like you would if it was in the table, right? You take the cups of baking soda from a word problem, you multiply by the constant of proportionality, and it tells you your cups of sugar. Oh, I was confused while I was doing this, and I understand why. This should be sugar. Okay, sorry about that. I'll correct it when I tell you, but that should be sugar. Okay, besides that, that's right. On the actual quiz, it's water. Alright, moving on. When you mix 2 colors of paint in equivalent ratios, the result is always the same color. A, complete the table so that there is a proportional relationship between cups of yellow paint and cups of white paint. Okay, so here we want to figure out what is the constant of proportionality and use that to complete the table. We're told it's a proportional relationship. So we want to figure out 2 times what equals 7. Okay, to find that constant of proportionality, we can do 7 divided by 2, which is equal to 3.5. So 2 times 3.5 equals 7. So that is going to be my constant of proportionality. And then I can use that, right? So 1 times 3.5, we have 3.5 here. 6 times 3.5, we'll have 21 here. And then if we want to figure it out in this direction, we're trying to figure out what number times 3.5 equals 17.5. So we can like flip it, go in the other direction. 17.5 divided by 3.5 is going to be 5. Okay, so we use the constant of proportionality to complete the table. The constant of proportionality is 3.5. Now we're asked again, what does it represent in this situation? We should try to find this 3.5 in the table because that's going to help us. Okay, again, we have in the table that when we have 1 cup of yellow paint, we have 3.5 cups of white paint. So that is telling me what this means. It's like my unit rate. I have 3.5 cups of white paint for every 1 cup of yellow paint I add. And then finally, we're going to write an equation that represents the relationship between the number of cups of yellow paint, Y, and the number of cups of white paint. Okay, a little confusing here. That Y is really like in the X spot. But we want to think about the second column, right? That's like the one we're trying to get to. So to figure out how much white paint we have, right? This is my white. This is my yellow. How do we figure out how many white paints we are? What did we do? Well, we took the amount of yellow paint, okay, and then we multiplied that by 3.5. Okay, so this is going to be my equation. You take the yellow paint, you multiply by 3.5, and you get the white paint. And again, that's what this table is showing. Yellow times 3.5 equals white. All right, last question. This one is going to be most complicated. It has the spicy level problems mainly, but it's very doable. So good for you for being here and watching. Okay, Miss O'Brien took 16 minutes to run 2 miles at a constant rate. Let D represent the distance Miss O'Brien runs in miles after T minutes. Okay, so we are going to write two different equations to represent this with two different constants of proportionalities. So what are two different constant of proportionalities for the relationship between distance in miles and time in minutes? Write these as whole numbers or fractions, no decimals. Okay, so this is what we have. We have that it's 16 minutes to run 2 miles. Okay, so what we want to do, right, we can kind of simplify this as a rate. This means it takes 8 minutes per mile, or in 1 mile. Okay, so that's going to be here, 8 minutes needed to run 1 mile. Okay, but we could also do the flip of that, the reciprocal of that, and we could say, okay, it takes 2 miles. 2 miles takes 16 minutes. So we could simplify that. That means 1 mile takes 8 minutes, right? Just like we kind of had here. 1 mile takes 8 minutes, which means that they can run 1/8 of a mile in 1 minute. Okay. So for that, you'd probably, once you'd get to this stage, you'd do 2 divided by 16, or you'd do 1 divided by 8, and then you'd get a decimal value for that. Okay, that would be the correct answer. You would get 0.125, but I'm asking for you it not in decimal form, but in fraction form. And that's because when we have it in fraction form, we can see this relationship. Okay, what is the relationship between these two different constant of proportionalities? These are reciprocals, okay? And we know that reciprocals, which is an important math word, means that they'll multiply to give us 1. So it's like they undo or cancel each other out. Okay, they multiply to give us 1. So reciprocal is a really key idea here, and the fact that we're going to write two different equations for the same relationship is because we have this special reciprocal relationship. Okay, awesome. So now we can write those two equations. Okay, and we're going to do it with our constants of proportionality. Okay, so if I want to figure out how much time, t, it took for Miss O'Brien to run a certain amount of distance, I'm going to take the distance and I'm going to multiply, right, by how many minutes it takes her to run 1 mile. Okay, so for example, in this case, it takes 16 minutes to run 2 miles. So if I think of my distance as 2, what do I need to multiply 2 by to get a time of 16? Well, that's going to be 8. Okay, my constant of proportionality. So this is my constant of proportionality in the direction of you're trying to figure out what the time is. To figure out how long it took, time, you take the distance, how many miles, and you multiply by your speed. You're going 8 minutes per mile. Okay, if we do it in the other way, if I want to figure out the distance and I'm told the time, so I'm told, okay, it's 16 minutes that she ran, and I want to figure out how many miles she ran, then I'm going to take that time and I'm going to multiply by 1/8. Okay, this is the same as taking that time and dividing by 8. So those are both right. They say the same thing. Doing 1/8 times t is the same thing as taking time and dividing by 8. Okay, but here we just can kind of like see this constant of proportionality a little more clearly. Okay, so again, these are like the same equation. Ultimately, they are equivalent to each other. All of these are equivalent to each other. They're just flipped around. So one of them is sort of framed in your given time and you want to find distance, and one of them is framed as your given distance and you want to find time. Okay, so those are the 3 spicy questions here. So definitely the hardest questions on the quiz. Okay, and then last we have, if Miss O'Brien walked 3.5 miles at this rate, how many minutes would it take? Show or explain your thinking. Okay, so I can pick one of my equations. In this case, I am told the miles. So that means I'm being told the distance. This is the distance that they told me. Okay, and I'm trying to find the minutes. I'm trying to find the time. So I'm going to use my equation time equals 8 times d here, because time is what I want to find. And to get it, right, I take my distance, 3.5, and I multiply by my constant of proportionality, which is 8. Multiply, and this is going to be 28 minutes when I multiply this. Okay, so that's another example of this medium level, because you have to use an equation and substitute in what you know. Okay. All right, so let me know if you have any help. Good job watching this video. Okay, go back and try any problems you missed yourself first. Good job, everyone.